क्वार्टर 1000 था। हम पूछ रहे थे डेंसिटी कहाँ दिया है।
Okay, thank you, sir.
Today we will start new topic. आज वॉल्यूम क्लियर है, मीन साउंड? हेलो,
सर क्लियर है सर.
ओके.
Yes, sir. Clear, sir.
Today's topic is stresses around opening. ठीक है, मीन्स if underground, this is surface and this is the underground, we make an excavation like this gallery inside the underground mine. This is the underground mine, let's say, or we make an opening like this arc form. So what will be the stresses on this gallery or arc? This is the excavated area. So on this area, this is the excavated area, and there will be a void. We have excavated this area. So due to the rocks present, let's say this is the rocks. Due to the rocks, there will be a stress on this opening from all the directions. So it is very important for any underground mine to first calculate the what will be the stresses from all the directions, means tangential and radial direction, shear direction of stresses due to the rocks on this excavation area to make an opening. Is it clear what we are going to find today?
वही सर टनल टाइप का स्ट्रक्चर में जो स्ट्रेसेस मिलता है वही
क्या
टनल टाइप का स्ट्रक्चर में
जनरल
सर
वॉइस थोड़ा
वैसे भी
वॉइस थोड़ा कम आ रहा है तुम्हारा बहुत.
Sir, tunnel structure में बोल रहा है.
अच्छा, tunnel structure. Yeah, same for the tunnel structure. In tunnel structure, you can see there is a stress due to these rocks from this direction, from this direction. In tunnel also, tunnel or underground mine. But we are mining engineers, so we will see for underground mines generally. Here you can see the openings. These are the excavated area, means white portion you are seeing. Here are the excavated area, and you can see how much force will be there or a stress will be there on these openings due to the rocks present upside of this or side rocks. So we will calculate these stresses on any excavated area. You all know this formula. Sigma r and sigma theta and tau theta.
Yes, sir.
Due to the stresses, when sigma x and sigma y and tau xy will be there on any rock, means obviously it will be in compression because it is we are calculating for underground mine and any tau xy. So you know the formula sigma r, sigma theta. Sigma r is the radial. Let's say this is the any small section you take. This is the small section of any opening. Let's say this is the opening, circular opening, but you choose only a small section. So in this small section, there will be normal compression sigma n on this section, a small section, sigma n, and this and a tangential stress sigma theta. You can see the directions. What are the directions of sigma n and sigma theta? This is called normal. You can see this is normal to the a small portion of opening. This is the small, we take the small portion of an opening. ये opening है, okay? any small portion हमने लिया, which is at a distance of r from the center. So normal stress sigma n is denoted by sigma n, and due to the side rocks there will be sigma theta. This is called tangential. ये tangential कहलाता है. This is called tangential. Sigma theta is tangential stress, and this is normal stress sigma n. And also there will be some tau, means shear stress, which is denoted by tau r theta. This is called shear stress. Okay. This portion is, ये सबको clear है? What is sigma n, what is sigma theta, and tau theta r?
Yes, sir. Clear.
Okay.
सर
So
टेंजेंशियल स्ट्रेस और एक बताया शियर स्ट्रेस है ना सर,
हाँ,
ये दोनों का अंतर क्या हो
this
जाएगा सर? दोनों तो
ये नॉर्मल है, ये नॉर्मल स्ट्रेस है, ये टेंजेंशियल मींस डायरेक्शन, इस डायरेक्शन में लग रहा है, मींस if this is the sample, ये circular opening है, if this is the circular opening, so if means in this direction, normal direction, ये point ले, if you take this point to calculate the in what is the stress in this point or in this area, तो ये sigma n हो जाएगा normal to this plane, and this will be tangential, means what is the tangential stress due to the rocks, and shear stress due to the rocks present in the nearby. मीन्स इसका कंपोनेंट ले लिया हमने, सिग्मा एन एंड सिग्मा थीटा, मीन्स ओवरऑल स्ट्रेस होता है ना, मीन्स ओवरऑल स्ट्रेस का दो कंपोनेंट में ब्रेक कर दिया हमने. One is normal and one is tangential. You can see one is in y direction, one is in x direction to this sample. So this is the sigma r and sigma theta. You can write, and tau theta value. Means if sigma x, sigma y, and tau xy is given, then it is asked that what is the tangential stress, radial stress, and shear stress. This is radial sigma r or normal. This is the tangential stress sigma theta. And this is tau r theta, shear stress. What will be the summation of sigma r and sigma theta? if you add sigma r and sigma theta?
sigma x plus sigma y.
Yes, means addition of sigma x and sigma y overall stress.
Yes, sir.
Have you written these three formula?
Wait, sir.
इससे बहुत क्वेश्चंस आता है. I mean, at least one question is sure from this topic. And totally formula based question. Written?
Yes, sir. Yes, sir.
Like in this diagram, you can also, it is clearly represented here of how sigma z is due to the vertical stress and sigma s due to the horizontal stress from x direction, and this is the excavated area, circular opening. And what is the radius? Radius of this opening is taken r. So at any point, means at any point from this distance, from this origin, means this is the center of the excavation, 0.193. So in this PDF, we will study about what will be the stress at any distance A, means not on this section only, but on the section which is greater than radius, means outside the excavation. You can see this, if this is the sample taken and this is the outside the excavation area, so what will be the effect of this excavated area on this sample also? We will also calculate this. This what will be the stress, sigma, radial stress, tangential stress and tau on any distance A from the center of opening. And R is the radius of opening. ठीक है? I think in this type of question, how it is solved? It is assumed that, let's say, sigma vertical or sigma z, you can represent on either way, is P. P का megapascal or let's say megapascal. It's not defined what is, but let's say megapascal. So sigma h or sigma x, if we consider h kp, kp means sigma h is k times sigma v. Means it k could be less than 1, greater than anything, but we assume that sigma h is k times of sigma v. Means sigma h is equal to k into sigma v. Okay? We just assume this. So To understand the formula, just assume this sigma h equal to k sigma v. Means if sigma v or vertical stress is p, then sigma x or horizontal stress is kp, and you have to find the sigma r, sigma theta and tau on any distance from the origin. Means this is the center, from center 0, 0, center of the opening. A can be from 0 to greater than r, anything. Okay, means 0 to infinity A का value, and r is the radius of opening, like this r. So this is the formula. If you write in sigma x and sigma z, you can write it. Is no need of derivation because it's very complex. And you have to remember this formula. First write this equation, and after that we will see the use of this sigma h equal to k sigma v to simplify this equation. Sigma t, sigma r, tau r theta.
सर थोड़ा जूम इन करिए.
ठीक है, अब दिख रहा है?
हाँ ठीक.
ओके. एंड सिग्मा थीटा क्या है? टेंजेंशियल स्ट्रेस. सिग्मा आर रेडियल स्ट्रेस. टाउ आर थीटा shear stress. And sigma x, sigma y, you know what is r? R is the radial distance of the element from the center of the opening. A is the radius of the circular opening. So यहाँ पर means in this formula A is taken as radius. A is radius of opening in this formula. So you can remember according to that. A is the radius of opening. R is any distance from center of opening. ठीक है? After solving 4-5 questions, it will be very easy to remember. Sigma theta equal to half of sigma x plus sigma z, or sigma y, you can say, into 1 plus a square by r square minus 1 by 2 sigma x minus sigma z, 1 plus 3a square by r square, r to the 4 cos 2 theta. हाँ, theta, what angle is theta? थीटा कौन सा एंगल है?
clockwise angle, sir.
Yeah, if
From vertical.
from with x-axis, center angle with the x-axis. X-axis is this x-axis. So this is the theta angle from horizontal. Actually, different book have different theta, but according to this theta, this formula, this theta is from x-axis. ठीक है? ये एंगल. फॉर्मूला लिख लिया?
Yes, sir. Yes, sir.
एक्चुअली ये मेरा प्रीवियस ईयर का नोट्स था.
तो कौन सा फॉर्मूला है सर?
क्या? ये मेरा प्रीवियस ईयर का नोट्स का था. क्या?
अच्छा, नहीं ये देख रहे थे, फॉर्मूला भी इसमें भी लिखा हुआ है ना सर?
हाँ, K is the when you take the value of sigma, मतलब P common means sigma x common अगर लोगे तो, sorry sigma z.
अच्छा अच्छा
After taking sigma z common and you know that, तो वो फॉर्मूला आएगा ये. Is it visual?
Yes, sir.
yes sir
Okay, means how this K came, वो करवा देता हूँ, थोड़ा आसान रहेगा.
सर वो के नीचे जाके बल्क मॉडुलस का काम कर रहा है ना.
बल्क मॉड्यूलस नहीं है, वो बस एक फैक्टर है. K is the only factor. What is the formula of sigma r? Sigma x plus sigma y by 2. फॉर्मूला जरा बोलते जाना.
सर अभी दो ठो सिग्मा आर के फॉर्मूले लिखवाए ना, आपको कौन सा चाहिए?
नहीं नहीं, ये वाला, बस ये वाला बोलो.
ये वाला ना.
ये,
हाँ तो 1/2.
ये this one we will derive right now. This one how P and K came, तो थोड़ा आसान होगा. will be more easy. Sigma x plus sigma y by 2. 1 plus a square by r square.
सर हाँ ठीक है चलिए. माइनस
नहीं, माइनस, sorry, it is minus.
नहीं वो
वो तो
प्लस
ठीक
है.
था सर वो
नहीं,
ठीक है
sigma
अच्छा
r
रेडियल का.
तो बाद
हाँ
में
हाँ
sigma
हाँ
r, sigma r. I am
माइनस है
writing for sigma r.
माइनस.
Yeah, minus. And
Plus
here I think
1/2 plus 1/2
प्लस
plus 1
1
upon 2
x
सिग्मा
minus
एक्स
z.
माइनस सिग्मा जेड
sigma x minus sigma z or sigma y. Then
1 प्लस
1
3a
plus
स्क्वायर
1 plus 3a
3a
square,
स्क्वायर
3a square by r square.
5
नहीं, 4 है.
और 4 है
और
सर
4
4 minus
माइनस 4a स्क्वायर बाई आर स्क्वायर
minus
अब ब्रैकेट
4a square by r square. ठीक है.
थोड़ा दिक्कत है फॉर्मूला में सर
अब फॉर्मूला रटना पड़ेगा, बहुत क्वेश्चंस आता है. नो
सर उसके बाद cos 2 थीटा.
टू थीटा भी छूट गया.
cos 2 थीटा छूट गया सर.
cos 2 थीटा चलिए
cos 2 theta. You have to remember this formula, और कोई उपाय नहीं है, बट आसान है, याद हो जाएगा क्वेश्चन बनाते बनाते. सो वी यहाँ पर लेट्स सी दिस इज द ओपनिंग. ओके, लेट्स एज्यूम दिस इज द ओपनिंग and you have to find any stress on this area. ठीक है, यहाँ पर, and this is a distance of r from the center and its radius is a and it is making an angle theta. Okay, or we assume that if this is p which is sigma y or sigma z. कंफ्यूज मत होना सिग्मा z और सिग्मा y में. सिग्मा x is the horizontal stress. ठीक है, ये सिचुएशन. एंड व्हाट इज सिग्मा x? p into k. K is the multiplier factor, means equal to k into
gamma into h.
sigma y. p क्या है? p is the sigma y ना.
Yes, sir.
p is the sigma x. ठीक है, any confusion up to this point? यहाँ अब तक ये समझने में किसी को प्रॉब्लम है क्या? We assume that sigma y is p और sigma x is k into p. K is any factor, number है कोई भी, and p is Pascal, megapascal और Pascal pressure. So take here, take sigma x common. Sorry, sigma y को कॉमन लो, sigma y को कॉमन लो. सिग्मा y कॉमन ले लिए. if we put out sigma y तो क्या हो जाएगा? sigma x by sigma y plus 1 minus a square by r square plus sigma y, taking sigma y common, sigma y by 2 sigma x plus sigma y minus 1. यहाँ पर सेम होगा 1 plus 3a4 r4 minus 4a square r square cos 2 theta. cos 2 theta, हाँ ठीक है. एनी डाउट यहाँ पर? ये कैसे आया? जस्ट हमने एक्स वाई को सिग्मा वाई को कॉमन ले लिया. मीन्स वी पुट सिग्मा वाई कॉमन. सो सिग्मा वाई, टेकिंग सिग्मा वाई कॉमन, इट बिकम सिग्मा एक्स बाई सिग्मा वाई एंड यहाँ पर +1 हो गया. तो व्हाट इज द वैल्यू ऑफ सिग्मा वाई? व्हाट इज द वैल्यू ऑफ सिग्मा वाई we have taken here? p लिया है ना?
Yes, sir.
p by 2. Now what is sigma x by sigma y from here? K right, plus 1 minus a square by r square. What is a? a क्या है?
सर ये तो आप
रेडियस
ऑफ सर्कुलर ओपनिंग था.
हाँ, a is the radius of the circular and r is the distance from
r
the,
जो है रेडियल डिस्टेंस.
हाँ. And sigma y here is p by 2 again. k minus 1 और ये सेम वैल्यू पूरा ठीक है. नाउ यू कैन टेक आउट p by 2 कॉमन. फिर से टेक आउट p by 2 निकाल सकते हैं कॉमन.
निकाल सकते सर.
और यहाँ पे मैंने 2 बार लिख दिया. p by 2, take out p by 2 common. What you will get? K plus 1 minus a square by r square plus k minus 1 plus 3a to the 4 r to the power 4 minus 4a square r square cos 2 theta. Means ये आएगा फाइनली सिग्मा r in terms of p and k when sigma कंडीशन दे दिया. बट गुड न्यूज इज दैट जनरली अब तक जितना क्वेश्चन है, मीन्स whatever the question is asked till now, in most of the times they gave value like that this will become 0. ये full value 0 हो जाएगा. When this full value will become 0, can you say?
when theta
equal to 45.
Right, when theta equal to 45 degree or theta equal to 45 degree, right? That or another value a का वैल्यू 0 हो जाएगा. हाँ, और कोई कंडीशन? एक कंडीशन और है.
A over our 1.
नहीं a equal to r, when a equal to r. means A equal to R means on the opening border
4
boundary.
- 4 हो जाएगा.
Yeah,
सर
boundary.
हो जाएगा.
So most of the questions which have been asked till now, in all the questions it becomes zero.
Sir.
The whole this value becomes zero.
Sir.
तो इसलिए टेंशन मत लेना. हाँ बोलो.
सर एक बार इसको थोड़ा सा समझा दीजिए ना, रेडियल डिस्टेंस ऑफ द एलिमेंट, हम इसमें थोड़ा कंफ्यूज हैं.
Okay. Radial distance of the element means this distance. Means if you want to calculate the means sigma or tau in any distance r from the center. Means ये center है. If this is the center of the opening, circular opening, तो any distance पर.
ओके सर, आपका जो ये रेड बाउंड्री सर्कल है वो मतलब ओपनिंग का एंड है सर.
Yeah, this is the opening. इसीलिए तो ये circular radius है. Means this is the circular opening और it has a radius a. So this is the excavated area inside the circle, and outside the circle this is the rock. Outside the circle there is rocks.
आप जो निकाल रहे हैं वो मतलब कि पर्टिकुलर एलिमेंट अगर इक्वल नहीं है तो कहीं ना कहीं पे रॉक पे है.
Yeah, particular element there is rock, and what will be the stress? Means there is a stress में changes आएगा ना distribution में due to the opening. So how this stress distribution changes due to the opening, and this is the radial distance r. If r equal to a जाएगा, then it will be here on the boundary. R equal to a.
So within the radius of the circle, मतलब कि अंदर में तो नहीं होगा, either बाउंड्री में होगा नहीं तो कहीं पर्टिकुलर एलिमेंट में होगा.
हाँ, उसका ग्राफ भी हम लोग देखेंगे आगे. हम लोग उसका ग्राफ भी देखेंगे. There is graph. See the graph also. Graphical representation भी आ चुका है क्वेश्चन. Okay. Now I am giving you. हाँ.
मेरे को लगता है मतलब जैसे सिर्फ एक assumption है कि ये वाला जो K वाला फॉर्मूला है ना, सिर्फ इसी को बस याद करने की जरूरत पड़ेगी.
हाँ, सिर्फ K वाला क्वेश्चन.
बाकी ऊपर वाला जो आप बताए उससे क्वेश्चन रेयर है.
नहीं आएगा. Means you have to only remember the formula of only this formula K and P formula. K and P formula. But for this you have to remember that what is P and what is K into P. In some questions they will give that this is the circular opening and this is the sigma. Sorry, this is Kp and this is P. ऐसे भी दे सकते हैं. They can give they can convert the K and P. So you have to take care of that. What is given in the question?
Yes, sir.
If you have used this.
So sigma x is equals to जो kp लिया सर उसका टर्म एक बार फिर से एक्सप्लेन कीजिएगा ना सर.
Okay सर. Sigma x is equal to, मान लीजिए कि सिग्मा v वर्टिकल स्ट्रेस. हाँ पूछो.
इसका मेरे ख्याल से इसका जो सिग्मा एक्स इक्वल्स टू केपी आता है ना, तो पी जो है वर्टिकल लोड है, तो सिग्मा एक्स मतलब हॉरिजॉन्टल अपॉन वर्टिकल इक्वल्स टू के हो जाता है.
नहीं, इनटू नहीं, डिवाइड.
हाँ, मतलब हॉरिजॉन्टल
सिग्मा एक्स बाय सिग्मा वाई
वर्टिकल इक्वल्स टू के. हाँ
या वही तो हमने यूज किया. दैट्स वी हैव यूज्ड ना. हाउ के कैम through sigma x by sigma y. Sigma x by sigma y is k, because if sigma v or sigma y you take it p लिया, okay, and we take sigma x equal to kp. These two things we have assumed to get this formula. We have assumed these two things. Sigma y is p and sigma x is kp. According to that we came to this formula. Okay.
यस सर. कभी कभी ऐसे क्वेश्चन में सर म्यू की वैल्यू भी रख देता है.
Yeah, अगर if question is asked that this is the opening, let's say this circular उतना
Poisson ratio.
हाँ, and this is kp and this is p. So formula different हो जाएगा. That's why I show you how to derive this formula. So I came from the general formula. This is the general formula. You should have the idea of this formula, and according to that you can calculate this formula. ठीक है? You should have idea that from where K and P came. You solve all types of questions. If any twist is there. ठीक है? Derivation, is there any problem in the derivation of how K and P came? कोई कुछ प्रॉब्लम है तो पूछो.
नो सर.
Okay, now I'm giving you a question that find sigma r when a equal to r.
Find sigma r when a equal to r.